Welcome to OnlineMaths TV. My name is Jakes Anemo, and today we have a very good challenge. But before we go into this challenge, I want to use this medium to say a very big thank you to all my subscribers, all my viewers all over the world. And I want to tell you that your comment, your words of encouragement has really pushed me far in putting in my best. And I promised you that in this channel, as far as mathematics is concerned, I will give you nothing but the best. In other words, I encourage you to stay connected all the time. Okay, and for those that are watching me for the very first time, maybe you just stumble into this channel for the very first time, I want to encourage you to subscribe, because in this channel we drop new videos every day. Why? Because mathematics is life. Mathematics is fun. So we have fun in this channel every day. Okay. With that being said, let's go to today's challenge. The question says y equal to 1 plus log x base 4. And x to the power of y equal to 4 to the power of 6. Then x comma y will now be what? What will be the value of x comma y? So let's take down our solution. Okay, selection. We bring down our question which says y equal to 1 log x base 4. I want to give this first expression equation 1. So let's label it equation 1. Then the second one, we have x to the power of y equal to 4 to the power of 6. And also, I want to give this equation 2. Now, in solving this exponential expression or equation, I want to use two methods. And out of the two methods, pick the one you feel suitable or best for you. Okay, so let's take the first method. Okay, the first method. So let's say here, first method. First method. Okay, now in the first method, I will take my equation 1. From equation 1, we're going to have here y equal to 1 plus log x base 4. Okay, now from this equation 1, which is what we have in here now, I want to collect 1 to the left-hand side. Okay, so if I do that, then I'm going to have here y minus 1 equal to log x base 4. This is a logarithm expression. I want to convert this logarithm expression into indices. Okay, so from here, we have here, say convert to indices. Convert to indices. All right, so let's move forward. Now, because of the strong relationship between logarithm and indices, we can rewrite this in index form. Okay, so let's go down and convert this. So the expression we have here now is the same thing as 4 to the power of y minus 1 equal to x. And so this now become 4 to the power of y minus 1, let's put this in bracket, equal to your x. Okay, what we have here now in index is this. So it also implies, this now implies that your x is equal to 4 to the power of y minus 1, close bracket. Now let's give this equation 3. Let's hold this guy as our equation 3. If you look at equation 3 and take a look at equation 2, you can see that there's a relationship between both of them now. Okay, now We have x to the power of y. We are having x equal to this. So we can substitute equation 3 into equation 2. Exactly. So now let's put it down. It says put equation 3 into equation 2. We go ahead and write down our equation 2. Our equation 2 says that x to the power of y equal to 4 to the power of 6. This is our equation 2. So wherever we see our x in equation 2, okay, let me put it down so that this is our equation 2. So wherever we see x, we put in equation 3, which is x equal to 4 to the power of y minus 1. So if we do that, this equation 2 will now become 4, okay, which is everything we have here, to the power of y minus 1, close bracket. This s is further raised to power y. So we put the y outside, equal to 4 to the power of 6. Right. Something special has played out here now. The base numbers are the same. So since the base numbers are the same, this will go with this. And so we can equate the exponent. So now let's go ahead and equate the exponent. The exponent is going to give us here y minus 1, close bracket, into y equal to 6. Open up this bracket. If we use y to open this bracket, it's going to give us here y squared minus y equal to 6. And rearrange, bring the 6 on the right hand side to the left hand side. This will automatically give us y squared minus y minus 6 equal to 0. Why this one we turn to minus on the left hand side is because we have invisible plugs here. Okay, now the reason why this thing is not seen, it is made so that you that is a mathematician will see it with your mathematical eye. So the ordinary man cannot see the plus here. Okay, so that's why you are special. You are different from other set of people. Mathematicians are great people. Okay, that's just fun, by the way. So now you have a quadratic equation. So let's solve this quadratically using factorization method. If you look at this, take the 6, which is the constant, and look for all the factors of 6. Now, if we do that shortly, we have here 6, and the factors of 6, 1, 2, 3, and 6. Among this number, let's pick two numbers that when we multiply them together, will give us minus 6, add them together, will give us minus y. So without waste of time, it's going to give us 2 and 3. And what would be the sign of 2 and 3? From this, we're going to have this to be plus 2 and minus 3. Okay, so let's check out if that will give us this. Plus 2 times minus 3 will give us minus 6. Plus 2 plus minus 3 is going to give us minus 1. So we got the two numbers. So let's go ahead and impute these two numbers into the column of minus y. So this we're going to have here y squared minus 3y plus 2y minus 6 equal to 0. Very good. Let's go ahead and put this in bracket, put this and this in bracket. Yeah, we look at terms that are common to each bracket and factor those terms out. So from here, we proceed again. Let's proceed from here. We erase this first. So y is common to this. So we bring out y. So if we bring out y, we're going to have here y bracket. Here we have y minus, because y into y square will give us 1y minus y into 3y. We are left here with 3. The plugs, what is common to this is 2. So we bring out 2 here. 2 into 2y will going to give us y minus 2 into 6 will give us 3, or equal to 0. Okay. You now discover that the term in the first bracket and second bracket, they are the same. And so we take only one out. So we're going to have here y plus 2 bracket, bracket, y minus 3 equal to 0. Okay. At this point in time, we apply the zero product property. Okay, so if we apply the zero product property, we are going to equate this to 0, equate this to 0. Automatically, we will having y plus 2 equal to 0 or y minus 3 equal to 0. So therefore, we now have y is equal to minus 2 or y is equal to positive 3. We've gotten the value for our y now. Then let's go ahead and look for the value of our x. How do we get the value of x? Let's bring our mind back to equation 3. Okay, look at equation 3. It says x equal to 4 to the power of y minus 1. So we now say from equation 3, okay, substitute for y. We pull down our equation 3. Equation 3 says x equal to 4 to the power of y minus 1, close bracket. So for case 1, where y is equals to minus 2, then we now have this, and say x equal to, for y minus 2, we're going to have here 4 into y minus 2 minus 1. And y, minus 2 minus 1 is going to give us here 4 to the power of minus 3. This expression, we can remove this minus sign according to the law of indices, an expression which says that if you have a to the power of minus m, this is same thing as 1 all over a to the power of m. So the 1 on the division sign has taken care of the negative power, okay? It's among the laws of indices. Now, I produced a video on the laws of indices, but I call that video the 7 pillars of indices. It's showing up here, okay? You can do well to watch it after this clip. Watch it and see some of the rules that are bind the operation and indices. Okay, so if I apply this law to this is going to give x here. X is equal to 1 all over 4 to the power of 3. And what is 4 to the power of 3? It means 4 times 4 times 4 into 3 places. If we do that, this is going to give us 1 all over 64. So for the first case, we have here x, comma, y. When x is 1 all over 64, so I have here 1 all over 64, bracket, comma, what is the value of y? Y is what? Minus 2. So I have here minus 2. Okay, now let us go ahead and solve for the other values. Okay, so from here, we'll now look out for case 2. Case 2 is positive 3. Okay, so for case 2, we now go back to our formula again. So we have here x equal to 4 to the power of y minus 1. Yeah, wherever we see y, we put in 3 there, positive 3. So this automatically will give us 4 to the power of 3 minus 1. And this is equal to 4 to the power of 2. And 4 to the power of 2 is 4 times 4 into 2 places. And this will give us 16. So therefore, we now have our case 2, which is x, comma, y. We're going to have here, a bracket open, 16, comma, positive 3. All right. So let's take the second method and see the one that is better. So second method, let's put it here. Second method. Okay. We put down our equation again. We have here y equal to 1 plus log x base 4. At the same time, let's still take this as equation 1. Let's label this as our equation 1. Then second one, we have x to the power of y equal to 4 to the power of 6. Okay, let's also take this as our equation 2. Now look at what I want to do in here now. From equation 1, I will take convert this one to a log form. Okay, if I change this to log form, the question is going to be, to what base am I to change this one? I will change it to base 4. Why? Because we are having log to base 4 here. Hence, log to base 4 should be applied here now. So from equation 1, I'll say here, from equation 1, you can write this as y equal to log 4 base 4 plus log x base 4. Why is it so? There's a law in logarithm which says that the log of any number base itself is equal to 1. For instance, if you have log a base a, this is equal to 1, provided a is not equal to 0. As a matter of fact, I have a video on about 9 laws of logarithm, the 9 laws of logarithm, and it's also showing up here. Okay, you can equally watch that video to see what is happening here. This law is also among the two. So if we apply this law to this, we're going to have this. Okay, from this point now, here is a plug sign. I can apply the multiplication law or product law of logarithm here now. It's also among the video, among the laws in the video. Okay, so if I change this to multiplication law, which says that if you have log m n base a is the same thing as log m base a plus log n base a. What we have here now is in this format. So I want to take it back to this form. So if I convert this to this format, this will automatically give us y equal to log 4 times x, which is log 4x base 4. Okay, so from here we proceed. Again, let's proceed from here and see what this gives us in turn. Let's erase this also. Don't need you here. Okay, now from here, what I'm going to do here is to convert this expression. If we convert this expression to indices, it's going to give us something special. So let's write here convert to indices. If we do that, this is going to give us 4 to the power of y equal to 4x. So we now have this to be 4 to the power of y equal to 4x. There is a strong relationship between a logarithm and indices, like I said in the first method. Okay, we divide through by 4. So you can see here, divide through by 4. All right, but before we continue again and again, if you are new to this channel, kindly subscribe, okay? And when you subscribe, turn on the bell notification button. You know what that does? YouTube uses its algorithm to notify you whenever we drop a new video, and you will be among the first to receive our new videos. Okay, let's go back again. Now we said divide through by 4. So we now have here 4 to the power of y all over 4 equal to 4x all over 4. The equation says, or the law of equation says, that whatever you do to the right hand side, you do it to the left hand side also. Now look at this. This guy is to the power of 1, divisible 1 here again. We are having the same base, and the division law of indices says that when you have a to the power of m all over a to the power of n, this is equal to a to the power of m minus n. It said subtract the power. So if we are to subtract the powers, then this expression will in turn give us here 4 to the power of y minus 1 equal to x. Therefore, our x is equal to 4 to the power of y minus 1. We can name this very guy here as equation 3. let's give this equation 3 because we have equation 1, equation 2, and now we're having equation 3. So what do we do here now? Let's strike a relationship between equation 3 and our equation 2, like we did in the previous method, the first method. So from here, we can now say put equation 3 into equation 2. We bring down our equation 2. Our equation 2 says that x to the power of y equal to 4 to the power of 6. So wherever we see our x, we put equation 3 into it. And so this will give us here 4 to the power of y minus 1, close bracket, raised to this y here. So raised to y, let me write this well, raised to y equal to your 4 to the power of 6. You can see that the bases are the same and there is an equality sign here. So the base will take care of themselves and we can equate the exponents. So this we go with this. So from here, let's proceed again. Okay, so the exponent we have here to be your y bracket y minus 1 equal to 6, open up to give us here y squared minus y equal to 6. Move this to the left hand side to give you y squared minus y minus 6 or equal to 0. This is a quadratic equation. Okay, so we can solve this quadratically by using the factorization method. So if we apply the factorization method, we're going to have this to be y minus 3 close bracket y plus 2 equal to this. Because we've done much work on this, so hence I just jumped to this stage now. So using the zero product rule, we equate this to 0, equate this to 0. And so we have here y minus 3 equal to 0 and y plus 2 equal to 0. Therefore, we have our y is equal to 3 comma minus 2. We have gotten the value of y. We can now look for the value of x. And if we cast our mind back to our equation 3, in our equation 3, we've made subject of the formula already. So we'll now say put y equal to 3 into equation 3. If we do that, we bring down our equation 3 first, which is x equal to 4 to the power of y minus 1, which is equal to 4 to the power of 3 minus 1, which is automatically 4 to the power of 2. And therefore, x is equal to 4 to the power of 2 is 16. So we have our first solution, which is x comma y is equal to our x 16 comma y positive 3. We go ahead and do that for a case 2. So let's move ahead again from here. Okay, case 2. Okay, we have here x equals to 4 to the power of y minus 1 again when your y is equal to minus 2. So this will now be 4 to the power of minus 2 minus 1. So we have this to be 4 to the power of minus 3. Again, we eliminate this minus sign from the law of indices. So we have 1 all over 4 to the power of 3, which is automatically 1 all over 64. Okay, this is our s. Therefore, the second case, which is x comma your y, is equal to our x being 1 all over 64 comma minus 2. Okay, so these are some of the method we can apply in solving this exponential equation. If you have learned something good, something special from these two methods, give our video a thumbs up, or at the same time your preferred method drop it in the comment section that this is the one you prefer, this is the better one for this. Because in mathematics or in exam where we try to beat time, we work with speed and accuracy. Okay, so at least you will prefer a particular method. It could be because of the time, it could be because of the simplicity. Okay, but whichever way, drop it in the comment section. Okay, thanks for always be there. Remember, I love you. Okay, and also all of us at OnlineMaths TV love you so much because you are always there for us. Bye for now.